I mean, if you get really loud, it might get you sort of in the background, but so
Hi, chat.
All right. It just records like my screen and my voice, and they're terrible videos. My voice is awful. Sometimes it's really loud and annoying, but it's better than nothing if you're not here. So for our friends like that we have. Inequalities today. It is very similar to equations, but for inequalities, these are things that are not equal or unequal, right? And that means that we are going to have either less than or greater than signs instead of an equal sign. Okay, so there are a few things that we have to do differently when we have absolute value bars and an inequality. Okay, so I'm gonna, like we did the other day, I'm gonna start off. I want us to consider like a really, really, really easy problem. Okay, I just want to think about the absolute value of x is less than 3. What numbers work for that? What numbers make that statement true? 2 would work. 2 would work. 1 would work. Does -4 work? Because if I do absolute value of -4 less than 3, if I plug it in, right? What's the absolute value of -4? 4 is less than 3. Is that true? No. So like -2 would work, 0 would work. Does 3 work? That's a good question.
It equals 2.
All right. Right, because absolute value of 3 less than 3 is 3 less than 3. What would make it work? If we had an or equal to sign, then that would work, but it doesn't. But now, like, I don't have to stop at 2 because a number like 2.5 would work, right?
Yeah.
Or 2.9.
Yeah.
Or 2.99. How do I show that on the graph?
You don't. You just like put it in a random place.
I can show it.
Oh, you just put it halfway to 3.
Halfway to 3 would be like at 2.5, but 2.9 will work.
Split it in half.
And 2.99. There is a something that we did whenever we're doing domain and range. If the end point was not included, what do we use?
Oh, it's your
Arrow.
circle.
No, arrow tells us what kind of circle. Open circle. So what I'm gonna do is I'm gonna put an open circle on 3, and then I'm gonna shade. And then same thing's gonna happen on -3. We can't actually use -3, but we can go all the way up to it. So when we put those open circles, that tells me everything all the way up to 3 counts. So 2.9, 2.99, 2.9999999 would still work, but we can't use 3 itself. Okay, and for our answers on these problems, we are both going to write our answer in inequality notation, and we're going to draw a graph for all of our a number line graph, and that helps us see which numbers we're using here. So these numbers are all the numbers that are less than 3 units away from 0. That's what ends up happening here. Now, not always, but most of the time, we'll look at some exceptions at the end of these notes. Most of the time, these problems, your answers are going to be between 2 numbers. So like here, my answers are between -3 and 3. We were looking for things that go for both of those things. We're going to look for numbers that are both less than 3 but greater than -3. They meet both criteria. So when we have a absolute value inequality that has a less than sign, these are and problems. Okay, so for this to work, we have to have 2 things that are going to be true, and I'll show you what that means here in a minute. Okay, so for the most part, you are going to solve these just like you did the equations. There's 2 things that are different. The first is that you have to pay attention to whether it's a less than or a greater than. because that's going to tell you whether it's an and or an or. The second is that there is something special that you have to do when you are solving an inequality. There's a special case that you're going to have to do something different than normal. Does anybody remember? You did inequalities in Math 1, but just not absolute value ones. If you, and I would write this down, multiply or divide by a negative number. Anybody remember what you have to do? No, it can work. Anybody remember? You flip the inequality sign. And we'll do one where that happens here. So solving equations and solving inequalities are basically the same, but you've got to remember this. If you divide by a negative, you got to flip your less than to a greater than. Okay, and I'll do one soon where you have to do that. You don't actually have to do it on this first problem here. So when you are solving this, the other thing I do want you to be really careful of, when you're solving inequalities, your work has to be neat and you can't flip-flop sides. Because if I, like, with an equal sign, for example, let me use a different color up here. With an equal sign, if I have x equals 3, can I write that as 3 equals x? Is that fine? Mm-hmm. They're both the same thing, right? With an equal sign, no problem. If I have x is less than 3, can I write that as 3 less than x? You cannot, because when you first learned about less than or greater than signs, like in elementary school, what did your teacher teach you about them?
Hungry alligators.
The hungry alligators, right? And the alligator eats the bigger number, right? So this alligator is eating the 3, but this alligator is eating the x. Those aren't the same, right? So you cannot switch the sides of the equal sign. Some of you do that sometimes when you're solving equations. With an equation, it's fine. It doesn't make a difference whether you have x equals 3 or 3 equals x. But you can't do it with the inequality. So be careful with that. These two aren't the same. Don't switch the sides. You got to work straight down and keep your work neat. Okay, so here we need to get rid of that 2. Rosario, what can we do to get rid of that 2? Okay, it feels like subtraction because it is a positive, right? But it is right beside of that bar, which means it's being multiplied by that bar. So how do we get rid of things when they're multiplied? You divide. So we're going to divide by the 2 right here. And so I got absolute value of x minus 3 is less than 4. Okay, so now our absolute value bars are all by themselves. With the equal sign, we just rewrote the problem twice, right? If you were not getting 2 answers to those problems that were on the homework, it's because you weren't rewriting it twice. So you're going to say x minus 3 is less than 4. You just drop the absolute value bars just like we had on the equations. Over here, though, we're going to write and because this is a less than problem. So and we're going to have x minus 3, and we need to change this to a negative 4. But you also have to flip the sign. So we're going to flip this to a greater than. Okay, so when you rewrite it, the first one looks, all you do is drop the bars. First one looks exactly like it was. The second one, you have to flip the inequality sign and change this to a negative right here. Does that make sense? Okay, and then you just solve them. So Yasmin, what am I going to do that first one to solve it? Very good. And x is going to be less than 7. We'll keep my and right here. And then, Nathan, how do I solve the other one? Also add 3, which is going to give me x is greater than -1. Now, one of the problems about and problems is they usually don't leave the answer like this. Like this is correct right here, but they're like most of the things I give you are multiple choice on these, because I give you most of your quizzes and tests on Canvas, and it's hard to type something like this in. So if it's multiple choice, they're not going to leave the answer like this. So one thing they might do is they might give you a number line instead of the answer. And the number line will help us write the answer a little better. So I'm going to make myself a little number line here. -1 would go over here on the left. 7 would go here. Okay? So when I see x is less than 7, that tells me put an open circle on 7 because there's no or equal to, right? And where should I shade? The numbers above 7 or below 7?
No.
Below. Because these are numbers less than, so lower than 7, right? And you can also, as long as the x is first, you can also kind of just go the direction the sign is pointing. So you got that less than sign. It's almost like it's got an arrow pointing to the left. That only works if your variable is first. But as long as your variable's first, it will work. So we shade that direction. And then I've got x is greater than -1. So that's here. And I want the numbers bigger than -1. So I would need to shade this direction. And I'm looking for where those two things overlap. And they overlap in between those numbers, right? Okay. So saying something that is less than 7 and greater than -1 really just means the numbers between -1 and 7. Okay. The way that you're going to see this written is sort of like we did for domain. You're going to see lowest number first, less than x, less than 7. Okay, that middle part's always the same. It's always less than x, less than. And then you just have your lower number and your higher number. Okay, and so this is how you would want to write the answer. Or they may give you the answer as a graph instead of the, a number line graph instead of the written part. Okay, questions there? All right, let's look at what greater than problems look like. Okay, greater than. So all I did here is I switched my less than sign to a greater than. So what numbers could I use on the number line that are greater than 3? Okay, 5 would work. 4 works. 6. Really keeps on going, right? Anything bigger than that. What about 3? Does 3 work? No, but I could put an open circle because you can go all the way up to 3, right? So this looks like all these numbers would work, right? Anything bigger than 3, 3.001 would work, right? And then anything bigger than that. Are there any negative numbers that work? Like if I tried -6, absolute value of -6 is greater than 3. What is the absolute value of -6? 6. Is 6 greater than 3? Yeah, it works. Okay, what's another negative value that works? 5 and 4. What about -3? Almost, but open circle, right? We can't use -3 itself. And we could shade here. Most of the time, but not always, whenever you have a greater than problem, your answers are like on the ends of the graph. They're not between two numbers, they're on the ends of the graph. And these are the numbers that are more than 3 units away from 0. Greater than problems are or problems. So like on that last problem, the answers that worked were less than 3 and greater than -3. They were between two numbers. Here, you've got like two separate sets. we could either have numbers less than -3 or greater than +3. There. And for some reason, I forgot to put the equation right here, so you got nothing. So let's make one up. I'm gonna do, let's do this. Let's do -2 absolute value of x plus 5 minus 1 is greater than, let me make sure I get some more. Actually, hold on. Hold on. I can't erase it. I need that to be a less than sign. Sorry, and I can't erase it. I need it to be a less than sign. And let's do -7 right there. Now, I said we're doing greater than problems. This is not a greater than problem. It's a less than problem. It was a greater than problem, but I changed it, right? I did that on purpose. Before you can decide whether you have a less than or greater than problem, you need to get the absolute value bars by themselves. Okay? So, Ben, what would we do to get these absolute value bars by themselves? Add the 1. Very good. Okay? So that's going to be -2. Absolute value of x plus 5 is less than -6. And then I've got to get rid of that -2. What would I do there, Ben? Good. I'm going to divide that -2. Now, if you're really good at solving inequalities, alarms should be going off in your head. What did we just do? We divided by a negative. What do we got to do if we divide by a negative? We got to flip the inequality sign. So, we're going to have x plus 5 is greater than +3. So, it didn't look like this was a greater than problem, but when you divide by that negative, it's got to flip the inequality sign. So, now it has turned into a greater than problem.
Don't we maybe do 2 problems so I get that to the list?
It will on one of them. You are correct. But if you don't switch it here, well, is that true? Well, it matters whether using like the word and or, which would affect whether it's like actually has an answer or is a no solution. So, so you want to make sure flip it here. Now we will have x plus 5 is greater than 3. That's one of our equations. Since this is a greater than sign, we're going to use the word or. And then we'll have x plus 5. And then right here, Brandon, what do I have to do?
With the for what it's called.
Inequality.
Inequality.
Yep. So I'm going to make it a less than. And then what else?
Yeah, 3. -3.
-3. Very good. Okay. Then we just have to solve these. So J. Ash, what do we do with that first one?
Subtract 5.
Very good. We subtract that 5. We get x is greater than -2. Keep that or there in the middle. And then, Darian, what are we going to do to solve that second one? We got x plus 5 less than -3. What do we do to solve that one? Good. We're going to take away that 5. And we get x is less than -8. Now, good news about OR problems is usually you don't have to put things together. This is not. So, if I graph this, I've got -8 and -2. We're looking for the numbers greater than -2. So we're going to use an open circle. We're going to shade the numbers above, so that's to the right. For x is less than -8, open circle, shade to the left. Okay, as long as those don't overlap, you can just write your answer like this. There's no way to write those together. So you're just going to say x is greater than -2 or x is less than -8. And that's what like the multiple choice answer would look like too. It's mostly the same as what we were doing yesterday. You just have a couple things you got to watch out for. Okay, let's keep going. Also, yesterday, I showed you how to do it on Desmos, right? So I want to show you, like, you can sort of do this on Desmos, but you can at least narrow down your answers, but you can't entirely do this on Desmos. So if I pull up Desmos here, I could still do f of x equals, and I would do the left side. So that would be absolute value of 2x plus 3. And then I could do g of x equals 6. And it's going to give me the numbers that I need. I got -4.5 and I got 1.5. But does it tell me whether or not we're talking about between those numbers or like away, like going out from those numbers? Doesn't tell you, right? So we have to do these by hand in order to get the like inequality right. But this does help you narrow it down, especially if you have multiple choice problems, because you know you're going to have -4.5 and 1.5 as part of your answer. It just, you don't know whether it's between or apart. In fact, though, you really got like a 50-50 chance of guessing that right. So like if we're talking on the EOC and you've forgotten how to do it, but you do remember how to do this, it probably is at least going to narrow it down to 2 answer choices for you. So that helps some. So, but let's do it by hand. We can do it. All right. First thing I always want you to do, and it's hard to remember to do this, is I want you to look at your inequality. If the absolute value bars are by themselves, are they by themselves here? Yes. I'm going to look here and see if I have a less than or a greater than. Okay. If I have a less than, I have a less than right here. This is an and problem. Not always, but most of the time, an and problem is between two numbers. I don't know why I colored that one in. It's not colored in on this one, but most of the time, it's between two numbers. In fact, I'm going to erase that because it's bad. Right there. This is an and problem. So we're probably looking at something that falls between those numbers. Okay, so Emily, what's the first thing that I need to do here? I can't do it yet because the bars are still there. To get rid of bars, we got to write two separate equations. What's the first, or inequalities? What's the first one look like?
2x plus 3
If I'm going to switch that to a greater than, I'd have to do a -6. Usually we write that one second. Yep, and the other one is 2x plus 3 less than 6. So you got one of them that just looks the same, right? This one right here, usually I write that one first. 2x plus 3 is less than 6. It looks exactly the same except for the bars dropped, right? And then this one, you got to flip the sign and make it negative. Okay? So, for this, Emily, what would we do to solve that first inequality? Very good. So we got 2x is greater than -9. And then after that, Emily, divide it by that 2. You can leave it a fraction or a decimal. I think I'll go decimal since we saw that on Desmos. -9 divided by 2 is -4.5. Okay, John, what do I do to solve the second one? Not the 6. We're trying to get the x by itself. The 3. Good. All right, so 2x is less than 3. And then? Huh? What are we going to do with that 2? Not subtract. Divide. Good. Okay, everybody good on that part? Now, they're not going to let you, especially for and problems, they're not going to let you leave your answer like this. Okay, let's draw us a number line. Negative 4.5 is here. Positive 1.5 is here. Okay, so here you'd have an open circle. You're looking at greater than negative 4.5, so those are the numbers here. And then you've got less than 1.5, those are the numbers here. So we're looking at those numbers in between. You should really always graph it because we are going to look at an exception here in a minute. But if you forget, you really could just do lowest number first, less than x, less than highest number. There. Okay here? All right, this is how you would write your final answer. And that just means all the numbers between negative 4.5 and 1.5. Okay? 4 is really similar, but this one is an or problem because we have a greater than. So for this one, we're going to just write the 2 separate equations. The first one, 2x minus 3 is greater than 5. You just drop the absolute value bars. They're gone. The second one will be 2x minus 3 is less than negative 5. Okay? And we can put the word or between it because it's going to be either one of these. Andy, how do I solve that first one? Very good. We're going to add that 3. 2x is greater than 8. And then what do I do after that, Andy? Good. We're going to divide by that 2. Very good. X is greater than 4. Okay, Brandon, what do I do on that next one?
Positive 3.
Good. So I got 2x is less than negative 2. And then?
Divide it by 10.
Very good. X is less than negative 1. You're probably just going to be able to like circle that as your answer. We should graph it to be sure. So you got negative 1 here, positive 4 here. X is greater than 4, so that's right here and all of the numbers above. And we got x is less than negative 1, so that is here and all of the numbers below. I'm realizing there's one thing I did not put. I don't know if I put it on these notes at all. Let's see if it shows up in a minute. Probably didn't do it. There's a couple right there. All of these have been open circles because I just use less than or greater than. If you have an or equal to, then you color the circles in, right? Okay. All right. There are 2 special cases that we have to watch out for. All right. You may even want to write this down. Usually, Less than problems are and problems. They usually are between two numbers. And greater than problems, we said are or problems. They usually look like this. They're two separate sets going away from each other, right? And they are what's the best way to write that? They're not between two numbers. I'm just going to put going away from each other. It's not the best mathematical language, but we understand, I think, what that means. You got those arrows pointing in opposite directions, right? Okay, this is what usually happens, but there are two exceptions to this. Okay? The first exception is that you have a number that is less than a negative number. Okay? So we got absolute value of x plus 2 is less than negative 1. What kinds of numbers are less than negative 1? Like negative 9 would work?
Bigger negative number.
Bigger negative numbers, right? All numbers less than a negative number are also negative, right? So this is definitely a negative number. Can an absolute value be negative? No. And less than negative 1 is definitely going to be negative. So whenever this happens, if you see right here that you have your absolute value bar is less than a negative, then your answer is no solution. Now you're going to have to catch yourself, because otherwise it is going to kind of look like you have an answer. What's going to happen is that's an and problem, and you're going to have a graph that looks like an or graph, which doesn't work for that. So you got to watch out for this. It's hard to catch a lot of times. The other thing you have to look out for is absolute value is greater than a negative number. Okay? What could you say about the absolute value of whatever is there? What is always true about the absolute value? In the end, it's going to be positive, right? Whatever comes out of that absolute value is going to be positive. So if I have, like, for example, here where it says absolute value of x minus 2 is greater than negative 3. I don't know what number this right here is going to be, but I do know that it is a positive number. Right? No matter what. Doesn't matter what you plug in, you're going to get a positive out, because absolute value. Did y'all like my shirt today? Did y'all recognize? It's, yeah, it's pretty nice. I'll show you where I got it on Amazon if you want one. So figured y'all are probably jealous. Is it true that a positive number is always going to be greater than a negative number? Yeah, positive numbers are always greater than negative numbers. So this statement is always true. So that solution is all real numbers. Or you might remember we used that that R with the double bar before. Whenever we were doing domain and range, you could use that as well if you don't have to write all those words out. Now, for the graphs, if you have to give a graph for no solution, it's just blank. Nothing's highlighted. And if you have to give a graph for all real numbers, you are just going to highlight the whole entire graph. It's everything, right? Most of the time, they don't give graphs if those are the answers, but they could. So that's what it'll look like. Okay, we're getting close. We're almost there. I want you guys to try these next three on your own. And I'm gonna freeze my screen while I work them out so you can't see what I'm doing. So try these next three on your own. absolute value bars. 5 minus x plus 4. So graph it for me. I'm going to say g of x equals, and I got 9. Okay, so here we go. Our answers are going to be 0 and 10. Okay, so if you've already solved that one by hand, that you should get those. All right, now I know I need the numbers 0 and 10. What I don't know, like let's say this is multiple choice. Let's say A is 0 less than or equal to x less than or equal to 10. And let's say B is x is less than or equal to 0 or x is greater than or equal to 10. I got both of those. There's probably 2 other answer choices. They may not have 0s and 10s, so we won't worry about that. How am I going to decide, if I don't know any more than this, which one of those it is? Okay? The way you can decide is this. There's a different color. Brown's ugly. Okay, I got orange right here, the sign. What kind of sign is that? It's a greater than sign. Sometimes when I think of this, I like to call it, you either have an and or problem. This is like a greater, less than, kind of works, you know. But this is a or problem. Or problems look like this because you want this or this, right? So if this is a or problem, which means your answer goes away from each other. It's not between the 2 numbers, right? So in this case, which one of these answer choices is the or answer where your answers are going away from each other? What does this mean right here when I say 0 less than or equal to x less than or equal to 10? What's it look like on a graph? Okay, this right here will make it where you don't have to solve them. You can do them with this one. Okay, so what's it look like on a graph?
It's like that. Wait, so now you're gonna type.
You can go up there, but you have to come back down.
Can I go with them?
No, definitely not. All right. Okay. Whenever you see this helps for domain and range. It helps for everything. When you see 0 less than or equal to x less than or equal to 10, that is all of the numbers between 0 and 10. Okay, so if it's written this way, that's between. Is that what we're looking for here? No, we don't want the numbers between. This is the or problem. When they're written separately, you will see the word or. So that's an indication that it's the or problem, right? And for this one, you're looking at less than 0. Those numbers are over here, right? And greater than 10, that's that direction. So they go away from each other. So you could pick answer choice B because it has to be a greater than. Okay. All right. Ones that are written like this are and answers, a less than sign. Ones that are written like this are or answers. Okay. Let's try that for the next one, and then we'll be done for the day. Okay. So for this next one, to solve it, you're going to go through those steps. But what a lot of kids have trouble with is getting, like, they can get the numbers right a lot of times, but then they're falling apart on inequality stuff. So let's look at this with Desmos. Okay, we're just going to do f of x equals left side, which is 7 minus x inside of the bars plus 2. And then the right side is 12. Okay? That will get us our numbers, -3 and 17. All right, so we could get that part without actually doing anything. So the problem in the beginning was -7 or 7 minus x plus 2 less than or equal to 12. You do have to move the 2 over first because really we need the bars by themselves. So we got absolute value of 7 minus x is less than or equal to 10. This right here is what we're looking at. It's a less than problem. Okay? And problems. They look like this. It's between two numbers, right? Or problems look like this. Two sections that go away from each other, right? So when we see this less than, this is an and problem. It needs to be between the two numbers, right? So to write your answer, I had not finished writing this. It's between your two numbers. Lowest number goes first. Less than or equal to x. Less than or equal to highest number. Okay, so it's going to be written like that. And it's mostly going to be multiple choice. So it'll be there for you. You have to recognize it. A lot of kids will forget the X in the middle or something. But it'll be there. You just have to recognize it. Okay. We're going to practice more with this on Monday. We have 8 minutes left. You, for the most part, may do what you wish. But you need to be sitting down. Okay, we're not going to line up at the door till like a minute or two before. So you can move if you want, but sit somewhere. Okay? You can get your phones, but you need to sit back down.